Okay, good evening, everyone. Welcome to our technical session of the month. All right. So here are the rules. Please be respectful to everyone. Keep your microphone muted. Engage actively by sharing your thoughts in the chat. Right. Speak one at a time. Keep discussions focused on machine learning. Avoid spamming the chat with irrelevant stuff. Join the session on time, and most importantly, have fun and enjoy the session. So our speaker for today is Akintunde Oladip. He is a research scientist working at the intersection of information retrieval and natural language processing for African languages. He co-founded the African Research Collective, which is currently focused on scaling large language models for African languages. He holds an MSc in computer science from the University of Waterloo and works as a senior applied research scientist at ServiceNow. Please give it up for Akintunde Oladipo. Over to you, sir. Stop sharing screen now.
Thank you very much. Please call me Tunde rather than my full name. Makes life easier
All right.
for everybody. All right, so I'm going to share my screen. I think I have permission to do that. Allow. Let me share. Just let me know when you can see my screen. Slideshow. All right, how are we doing? All right, that looks good. So I'm going to talk about data and language models for African languages. My name is Tunde Oladipo. I currently do most of my research work under the umbrella of the African Research Collective, which I started myself and Odoayo Ogundepo. Both of us are alumni of the University of Waterloo, and did most of our MSc research, within that area. So what this talk will cover, first of all, is what this talk does not cover, because language models, AI, is a very broad field, and it's impossible for us to cover everything within the 1 hour we have here. But I'll cover my research experience and interests to provide proper context. And then I'll talk about what languages interest me, how effective transformers are, how we can scale them, some of my own experience scaling language models for African languages, and what the LLM scaling laws say about these efforts. I'll talk about how good existing language models are, and some of the limitations that we have currently when scaling language models, and then opportunities, and then ongoing work at the African Research Collective. So I'm aiming for around 30 minutes, right? So that we spend the remaining, hopefully like 20, in a much more interactive fashion, right? So this talk shouldn't be too long, but so the first thing this talk will not cover is in-depth explanation of transformer architecture. Transformers are very popular for language models these days, and there is a lot to them, to their mathematics, to their construction, and we won't go into that at all today. And I will also not cover hyperparameter optimization, MILP parameterization, and other such like in-depth mathematics for the way that we select parameters for transformers. And I will also not cover transformer mathematics, which is formulas that tell us what size of model should you train for what value of loss, right? So the main thing that I will talk about will be just scaling these LLMs. I will assume some base knowledge, but you will also have the opportunity to, ask me some questions, and hopefully we can find answers. So my own research experience, I started with AI Saturdays Lagos, first with their ML cohort anyway, and then immediately after with their research cohort. And my research lead was Oreva Haya. who's currently doing a PhD at University of Washington, and I think she's interning with DeepMind currently. At the time, we were focused on the way that we can build dialogue systems for African languages, so just chatbots in African languages. In 2020, this was a pretty daunting task, and it didn't really work out as well. But in 2021, I got to work with InstaDeep as a research intern, and most of my work was looking at the way that we can compress language models. And it's very interesting, like looking back at it now, because at the time, OpenAI had just released GPT-2, and it was, I guess at the time you would have considered a really large model, but these days it's really small. I believe it was around like 200 or 300 million parameters. And we were looking for a way to make it smaller, even smaller, so that we could serve it to clients. And that was the subject of my 6 months research internship with InstaDeep. And shortly after that, I started my master's at the University of Waterloo in 2022. So I joined as a research assistant to Professor Jimmy Lin, and most of my work became about information retrieval and about scaling language models for African languages. So I did that for about 2 years, and then I joined ServiceNow as an applied research scientist. And most of my work now is like reinforcement learning for math, coding, and instruction following. So most of what I will talk about today is drawing from this experience. And I guess aside from this, I have some engineering experience in between that is not shown here at all. And my research interest, I'm very interested in cross-lingual information retrieval and question answering. So cross-lingual means that you have queries that are in African languages, and you have documents that are either in Arabic or English, French, or Portuguese. And this really interests me because this is very often the way that information is stored in African countries, right? We have a lot of documents that are in English or that are in French or Portuguese, but very often a significant portion of the population only speaks an African language. So, how can we bridge that divide? I'm also really interested in large multimodal models that can serve African language speakers, partly because, I watched OpenAI scale ChatGPT from, what it was when I started my internship at InstaDeep to what it has become today. And I'm like, I want something like that for African languages. I'm also interested in competition, which is kind of like collaboration as well as competition within the African language research space. I feel like more of us need to do research, more of us need to collaborate, more of us need to compete. Is really what makes life interesting. All right, so let's talk about Bender's rule, which says always name the languages you're working on. In this case, African languages, which is a really broad term to use. There's so many languages that we have, and for some of them, we have very little data. Right, I'm talking probably less than 200, like less than 1 gig in total. Right, some even far less than that. It's probably just megabytes of data that we have. So like, how do you decide what African languages that you can work on? Right, in my previous work, I've tried by looking at all the countries in Africa and then picking their top 2 or top 3 languages. But also sometimes to just get all data across all languages that I can in Africa. And then I just kind of pick a, what do I call it, a threshold, right? Below which if I don't have data, let's say up to like 512 MB or like a certain number of tokens, then, we can work with that language for these purposes, right? But Benda says, let's always name the language we're working on. So I will try and do that eventually during this talk. And most of my talk today will be about transformers, because they've become the de facto architecture for language models. And transformers are so really interesting because they allow us to efficiently use compute, but also like they can work across a variety of data modalities. So it can be text, it can be image, it can be audio. Transformers are seemingly able to just work across everything. And this transformer architecture that I've posted is the original vanilla transformer architecture. So you can see that it has both an embedding stack, an encoder stack, as well as a decoder stack. right? These days, people train either one or the other. They either train just the encoders or they train just the decoders. And both of them are useful for different things. So something like ChatGPT is decoder mostly. It's a decoder only mixture of experts. Um, but something like BERT is an encoder model, right? And if you want to scale LLMs, there's a variety of axes on which you might decide that you want to scale. It might be compute, data, or model, right? So if you want to scale compute, you could decide to train on a lot more GPUs, right? And this is probably like the most common way to scale. You could just technically repeat the data that you have for multiple epochs and just continue training. You could also try and improve your utilization of your GPUs. So you have the same amount of GPUs, but like, can we use it more efficiently by, for example, writing optimized kernels for some of the operations in your transformer architecture? And then you could also do like inference time scaling, which is like, like at test time, when you are, for example, translating a sentence, you could create like 5 translations in parallel and then use the same model to pick the best translation. So you might call that inference time scaling of compute. On the data side, you could decide to get more data. You can decide to get more data, higher quality data, or like diversity of data. There's obvious limitations, especially for African languages, right? There's a limit to how much data we have, especially like quantity and diversity. Those are 2 things I think I will talk about also. And then you could decide to get data that is like supervised fine-tuning or reinforcement learning data. Obviously, these are expensive to collect. You require people to possibly write them down or to annotate them. But it's one of the ways that you can scale. Just get a lot more data so that your epochs are larger. And in terms of the model themselves, one of the ways I've spoken about previously was to decide to train an encoder only or to train a decoder only. And if you train an encoder only, then you for the same GPU, for the same amount of compute, you could do more training simply because you don't have an encoder decoder architecture anymore. Same thing also for decoder. For the same amount of compute, you could do more, right? So one of the ways that you can do is to, the architecture, just do an encoder only or decoder only. You could train a deeper model, so have more layers in your model, or a wider model, so you're able to fit a larger amount of text. You could increase context length. These days, people train for like 32K. Obviously, that requires more GPUs and possibly specialized training frameworks, but it's one of the ways that you can scale. You can train a mixture of experts model, and the mixture of experts is kind of similar to the decoder architecture here, except that where you have that feed-forward network, instead of a single feed-forward network, you would have like n feed-forward networks, which function as independent experts, and to which you route different input tokens. So you could train a mixture of expert models. A lot of models that release this are a mixture of experts. And then you could train multimodal models. That is, models that support other modalities apart from text. So your model could, for example, have support for audio or support for images also, right? So there's a ton of ways to scale LLMs, but the easiest ones are probably the ones that I emboldened. So getting more data, that's quantity, quality, and diversity, and then training deeper and wider models, and training on more GPUs. And then, all right. So let's talk about Affectiva V2, which was my own master's thesis. And so Affectiva V2 is an encoder-decoder model. It was it's V2 because there was a V1 originally trained by Ogundepo et al. And Ogundepo trained his own Affectiva on only 1 gig of data. So, when I started my master's thesis, my first question was, can we get more than 1 gig of data? And that's kind of what led to like Affectiva V2. So the first thing that I think I did was to do web crawling for close to about 6 months to collect way more data than we currently had at the time. And eventually I pre-trained two sizes of model, the 428 million parameters and the 1.2 billion, which I think was the largest at the time for African languages specifically. I pre-trained for about 500,000 plus steps, batch size 512, standard language modeling, and I used TPUs instead of GPUs, and I used JAX instead of PyTorch. Now, there's a big reason for that. First of all, using TPUs because they were the only ones. Google was the only one that was willing to give me enough compute to do this work. You know, I couldn't get enough GPUs, someone to pay for enough GPUs to do this work. Because training took about a week, right, to complete across, all the languages that we supported and the data that we had. And since I was working on TPUs instead of GPUs, it made sense to use JAX instead of PyTorch. So yeah, so sometimes I get questions about why the Afritiva V2 REPL is in JAX instead of PyTorch. And the reason is because of compute limitation at the time. And in order to train Afritiva V2 at this size, in order to grow from like 1 gig of data, which previous researchers used to 30 gig of data. One of the things that I did, first of all, was to clean MC4, which is like an existing data set for across like 120 languages. But apart from cleaning MC4, was to crawl a total of like 1.3 million new articles across, I think, 16 African languages. And then to add that to Wikipedia, as well as the clean version of MC4, and then to perform deduplication, right? So that at the end, we end up with about 19 gig of data for African languages, to which I then added about 10 gig of data across Arabic, English, French, and Portuguese. And these 4 languages are mainly because they are the lingua francas that are common in Africa. So most African countries will have one of these languages as their lingua franca. So Nigeria has English, Benin Republic, for example, uses French. I believe Angola has Portuguese, and Arabic is common in like Northern Africa. So the aim is for our language models to be usable across, the languages that people actually use in real life. And that was the reason for adding those 4 languages. So like off the bat, we've kind of made progress from where we are coming from. Like I've been able to go from 1 gig of data to about 19 gig for African languages, and that was some progress. So I'll show some cherry-picked results, right? Instead of everything, just results that allow me to talk about, okay, like what did scaling data do for us, and like what gaps still existed even after doing that. So I'll look at machine translation, right? This is for a case of translating from English or French into an African language, right? And I'm using the Mafand MT dataset created by Adelani et al. So you can, in this table, the model that was scaled was Afritiva V2 large, but you can directly compare it to Afritiva, which is not included here. You can compare it to other T5 models that existed at the time. And we see significant improvements across board, but with like noticeable, what do I call it? Noticeable gaps. So for example, with Luganda, with Luo, and with Twi, we are like way behind models like Afribyte T5 base, So the reason for that is because these 4 languages were not included within the pre-training data for Afritiva V2 large. So like what I find is even when you scale data for some languages, for languages that did not exist in our pre-training data, the model's performance still fell short. So scaling might help within like the languages you're interested in, but it doesn't help generalization to unseen languages. In contrast, something like Byte 5 base uses a different type of byte tokenization, so it allows it to better adapt to new languages. And you see that across all of these languages, like Byte 5 base is the best performing language. Same for when you're translating from French to an African language. All of these languages are not included in Afritiva V2's pre-training data. Because if we go back, you can see I mostly focused on African, Amharic, Chichewa, Hausa, Igbo, Malagasy, Sesotho, Shona, etc. So scaling pre-training data alone does not help us generalize to new languages. So that's already like one um, drawback that we find. But for the languages that were included in the pre-training data, the improvements are significant. We go from like 9.3 for Byte 5 base to like 12.9 on Hausa. And for Swahili, for example, we go from like 24.7, 26.7 on MT5 to about 30.8. And what else? Same thing for Yoruba also. We go from like 7.6 to like 10.9, right? Translating into Yoruba. So we do see like significant improvements for the languages that we included in our data. But for like languages not included, we fall short. So scaling doesn't help there. And like there's evidently like other techniques that we're going to need to incorporate. In the case of cross-lingual question answering also, it's for the languages that we did include, the performance boost is very significant. So like Hausa, Igbo, Kenya, Rwanda, Yoruba, and Zulu are all included in the pre-training data for Affectiva V2. And what happens is we see significant improvements in cross-lingual question answering here. So you see that like we go from 39.7 on Hausa to 45.4, 40.7 on Igbo to like 57.1, and Yoruba also 21.8 to 37.6. And by the way, cross-lingual question answering is kind of, a case where you have questions in African languages, and then you have the answers in what is it called? In like English or like a high resource language. In this case, it was English anyway. But for like Bemba and for Twi, which are two languages that are not included in our pre-training data, results are still pretty strong, but like we don't have the best results. So, we are better than Affectiva base, which is the original model, and we're better than MT5, but we're not better than Afri MT5. And we're not better than on Twi also. Like we're not better than any of the previous existing models. So I guess like scaling helps, especially for the languages that we do scale the data for. And the performance improvements are significant. But for languages that were unseen, we find that we need to find new techniques. Right. And at the end of Affectiva V2, at the end of scaling data from like 1 gig to about 19 gig of data and training a 1 billion parameter model, some of the things that I found was, quality versus scale. It was difficult to separate like the improvements I was getting from scaling the data compared to like just having higher quality data, because I had both of them. My data was both high quality and like much larger than everything that existed before, right? But also like the importance of high resource languages. That's previously when people trained like the language models for African languages, they wanted to train it without English, without French, without Portuguese, right? And that was because like there was a need to prove at the time that we can train language models for African languages on African languages alone, right? And like my argument, when I was writing my own thesis was the fact that, okay, we can do it, but it's not useful for us because in practice, the way that we use our languages requires some interaction with English or some interaction with French, right? And then when generalizing to unseen languages, that languages that are not included in pre-training data, we still fall short. So like we need additional techniques to sort that, right? But also there's opportunity for decoder-only models in the fact that Affectiva V2 was encoder-decoder, and as well for instruction fine-tuned models, which are models that are able to follow instructions, something like ChatGPT. Also compute optimality. In all of this, like when training the model, the objective was... Did somebody have a question? All right, I'm going to go ahead. And in all of this, when training this model, the objective was to just scale the training data, scale the model, and then see what we get. So there was no there was no consideration of compute optimality, right, which I will define in subsequent slide. And then utility was encoder-decoder models aren't as optimized for inference as encoder models or decoder-only models. So even though we had a great model, using the model in production was still really difficult. And then the last thing is the affective V2I. It's an interesting thing where, when I pre-trained affective V2 and released it open source, people wanted to take the model and then use it as a chatbot. And that was difficult, mainly because of the fact that like the affective V2 is not an encoder model, so it's not trained to complete sentences in the way that people would expect a chatbot to do. So what happened was when people would prompt affective V2, they would get eyes returned by the model. So the model returned this smiley, exactly like this. It was very confusing to people why exactly this behavior persisted. But it was due to a mismatch between like what people needed at the time and what affective V2 could do. So if you wanted to go by scaling laws, right? Scaling laws kind of tells us if you give me a data set size, model size in number of parameters P, and a particular compute budget in flops, what should I expect concentropy loss to be at the end of training, right? If you go by Chinchilla scaling laws, then they say that a compute optimal model should have data set size in tokens to be equal to 20p. So already, if you look at affective V2, I said that it's about a 1.2 billion parameter model, and that means data set size should have been 20 times 1.2, which will give us around like 24, I think, 24 billion tokens, which is, I had far less than that when I was training. In my own case, I had, I think, 5 billion tokens across all the 16 African languages that I trained for. So already, like, I'm below compute optimality. And if you relate that also to the compute requirement, it's about C is equal to 6 PD. P again is like number of parameters, and D is data set size, right? And then when you want to make inference, it's about 1.2 times the total size of the model. And the main objective of scaling laws really is to allow you to plan ahead. So if I know that I want a 1 billion parameter model, then I know how much data I do need to achieve that. And then I can estimate how much compute I need and how much I would need to use this model in production. So like scaling laws, which came out, I think, after my own work, allows us to, I guess, plan for production before we start any kind of pre-training, right? So if we look at models that have been trained with scaling laws in mind, or that have large-scale models that currently exist, how well do they do across a variety of tasks in African languages? And this was work that I did with researchers at McGill, including Professor Adelani, and it was led by Jessica Ojo, in which we evaluated a lot of frontier language models across, I think, about 60 tasks, across about 60 languages on close to like 30 different tasks. And these tasks, they are grouped here. And then, we can see that, of course, like the closer you are to the circumference here, the better the performance of the model on that task is. So you can see that like the two best performing models are GPT 4.0 and Gemini, right? Which are two proprietary models, right? The ones that are internal, the worst performing models happen to be the original Gamma model, as well as models like IA 101 and Llama, even though Llama is pretty large at 70B, right? Considerably large. And then we can see that on tasks like test classification, models already reach saturation on the task, as well as intent classification. But on things like translation and mathematical reasoning, models still fall short. So there's still some gap, right? They're able to do like the simplest of tasks for African languages, but when it comes to tasks that require actual reasoning, or tasks that are reading comprehension, or that test general knowledge, even frontier models still struggle for African languages. And Honestly, maybe that is not surprising if you consider the fact that the objective of most of these frontier labs is to be able to serve in high resource languages like English, like French, or like lately even like Chinese, right? They don't have enough incentive to consider maximizing performance for African languages. So I suppose it's left to us. And then you might ask, why aren't there a lot of African languages, African LLMs on this chart? And the answer really is we haven't had models at this scale able to perform this well. We've had Nkuba LM, which is a small language model that supported, I think, about 6 to 10 African languages. But it has serious limitations when evaluated on this task. So it's not reported here. And I think we've had also like a couple of open source releases where people have taken models like Llama and then fine-tuned them for specific language. But because they are fine-tuned for such a narrow, like for a specific language, they don't generalize across a lot of African languages. So we also cannot include them here. So I guess that exposes like some of the limitations we have, right? The first thing is that we need more PhD students. And like, whenever we say this, it seems like, okay, like what to do. But the real thing is that the real problem is the fact that many of these are really difficult problems and it needs somebody committed to solving them. The duration of, for example, a master's program is so short that by the time you find your feet, you're done with your master's and then you move out. And, I say that because I did a master's also, and I found that like I wasn't done solving all the problems I was interested in before my program finished. And then I had to move ahead to the next phase of life. And we need also like more African AI labs, which is also part of what I hope that we can accomplish at Tarisco. An opportunity for us to like commit to like solving problems for, within the African LLM space. Then there's also like compute cost. I mentioned earlier that I had to train on TPUs given to me by Google instead of GPUs, simply because of the sheer cost of GPUs, and then there's data requirements. There's not a lot of web data for African languages, and there's not a lot of data across some domains also. So for example, to find data in legal domain for African languages is such difficult work. And that like narrows the set of skills that any language model built for African language can acquire, simply because data within that domain does not exist. So I think these are like the biggest like limitations that we have to scaling language models for African languages. But the good thing about it is that if you do solve any of these problems, you have the genuine pleasure of being able to gloat about it. And by gloating, hopefully, you inspire somebody else to go and solve some of these other problems so that they too can gloat. And this sounds hilarious, but that is often how like artificial intelligence advances. Somebody's going to come and say, hey, I have the best model for African languages. And somebody's going to narrow their eyes and say, you know what, I want to do better, or I can do better. And honestly, you are able to, because we are really early. And I say we're early because like we still have some of the same limitations that we had earlier. So it means that like starting from today or from whenever you're ready, that you can jump into LLM research for African languages and still make a serious impact, still make a foundational impact, right? You can do this by visiting fundamentals, for example, tokenization. Now, tokenization is really interesting because if you understand it, tokenization is the way that we start from taking a document and breaking it down into like individual tokens that language models can understand. And up to today, right, there's been limited work in designing tokenizers that are specific for African languages. What usually happens is that we take all of the tokenization assumptions that frontier AI labs have created and that are mostly adapted to English, and then we just train them on our languages. Now, we found that this works fine, right? But you have the opportunity, if you are really interested in that area, to like break down these assumptions and see whether there's improvements that we can make there. Yeah. And then there's also like data sources, right? When I worked on Affectiva V2 and when I released the Wora data set, I focused on the way that we can collect enough of the web text that exists for African languages, but there's still so many data sources that have not been unlocked. So there's data in audio, there's data in videos, there's data in books that, for example, have not been unlocked currently for African languages. There's also like complementary tasks. If you are going to like scale data, for example, then there'll be tasks like language identification, like OCR, like summarization, like audio transcription, right? That you can work on, that will unlock new data for working with African languages, right? And then there's evaluation results of LLMs. So like there's a variety of LLMs that have been released daily. And when we created Afrobench, we were able to evaluate some of the like top models. But as new models come, you could contribute evaluation results. That is, take the model and evaluate it using the Afrobench suite on LMeval, and then contribute the results back to the Afrobench repo. So what I would do is allow us to continue to keep track of how well new models that are released do, all right, on the Afrobench. And then you could honestly create evaluation data sets to measure specific capabilities, right? And an example of this is physical common sense reasoning. So physical common sense reasoning is where you look at the way that language models are able to reason about physical objects. So like, for example, being able to understand that um, if you want to carry a hot object, right, the best thing to use will be to use a napkin rather than paper, because rather than, let's say, steel, let me say paper, because napkin offers like better protection from the heat, right? So that's physical common sense reasoning. The main thing is if you can think of a capability that you need your language model to have, then you can think of a data set that measures that specific capability. And we simply don't have enough evaluation data sets at present to measure all different capabilities that matter for language models for African languages, right? Another thing that you could do is to look at edge LLMs, and edge LLMs are language models that are deployed at edge, that is on mobile devices or on what do I call it? On other edge devices like sensors and the things. And you could look at how well, that the language models perform in this area. Like how fast can we serve the models? How well do they do? How much performance loss do we get? And then you could look at things like tool use and MCP as substitutes for full language support. That is, if your model doesn't fully understand the language, can it make use of tools to sort of like supplement or complement its current abilities in order to better be able to serve like African populations? So this is only a subset of things that you could do, get into LLM research. But the fundamental thing is the fact that there's still so many limitations that is effectively still day one, right? There's still like so much that you can contribute. The field is not far gone, right, that you cannot catch up. And I think that this is one of the things that we're trying to do at Taresco, is the fact that, we feel like it's still really early and there's still so many unanswered questions and there's still so many low-hanging fruits, and we want to be able to tackle some of this. So like, I'm still really obsessed with scaling pre-training data, mainly because, when I discussed the scaling laws briefly, I spoke about how we're still not compute optimal. If you go by the 20 PD calculation in terms of data that we need, then like we still need additional 15 billion tokens, and I'm looking for those, right? But also we're doing OCR to see how we can unlock like data that exists in books, in written text, and also like reasoning, which is kind of like some post-training work, but looking at the way that language models can reason in African languages, even just arithmetic. It doesn't have to be something complex like polynomials or graph theory. Arithmetic is fine enough. And then creating new evaluation data sets. Currently, we're doing physical interaction question answering because there's a shared task at the conference that requires that. So these are some of the things that we're doing. Obviously, like things come and go, depending on the interest of myself or Odunayo, or whoever is working with us or where we're collaborating at the moment. And in terms of like opportunities at Taresco, early this year, we started Taresco Bounties, which is a way for us to throw open tasks to the community for people to solve for a token. The first task that I think we threw out was some LID work related to Afro LID by Feadebara. And We also had our first NLP research fellowship, in which our first fellow, Esther Denuga, a linguist, has been working with myself and with Odwayo on a paid year-long fellowship with us. We're still taking lessons from both of these things, but we think that there are opportunities that will remain open for the foreseeable future. Apart from this, we are in discussions and collaborations with other people across Africa, because that really is how we can achieve some of the objectives, that we have by collaborating with people. And yeah, so I think that's pretty much it in terms of like what we're doing at Tarisco to scale data and language models, African languages. So we can leave the floor open now, and if anybody has any questions related to this area, I'd be happy to talk with them.
Okay, everyone, if you have a question, please drop it in the chat. Thank you. Thank you so much for the talk.
I think because I'm presenting, I can't tell if anybody asks a question. So if you could help. Oh, I see.
And some people, I'm seeing someone about to drop some questions.
Let me just move things around. Okay. Oh, I see now. Can we just unmute and ask the questions? I don't know, moderator, you could pick one by one if people can raise their hands.
All right. If you have a question, please raise your hand.
So I have a question.
Yeah, please go ahead, Usman.
I was working with N8N framework. You know N8N. It's an open source.
Yes, correct.
So is there any African language model that I can integrate into N8N to use for my projects?
Why don't you try Llama?
Llama.
Yeah.
Okay, like, yeah, is there voice recognition?
Voice recognition?
Yes.
That
could recognize like Hausa language.
When you say voice recognition, you mean like transcription?
Yes, it will transcribe and execute.
You know what? You could try speech, for example, but that's a really interesting area. So, for example, for audio, for African languages, there's very limited work that has been done there, right? So it's something that's really still open for anybody to do work in. But
so
if you
I'm sorry.
Yeah, if you want to create a transcription model, you could try fine-tuning Whisper, for example, right, to achieve it.
Okay.
Yeah.
For the African recognition language like Hausa,
Yeah.
is there any open source I can fork and maybe improve it on my own?
I would say Whisper. If you know Whisper by OpenAI,
yes, and
yeah, then you should be able to use Whisper, I think, for what you want to do. If you can aggregate all this data and fine-tune, right, you should be able to get a decent model that works for what you need.
All right, thank you.
Another option, like I said before, is to see people like speech. I think they serve like transcription APIs. You can see how well it works for your languages, like Hausa.
Okay, for which platform?
Speech. It's a company. It's a Nigerian company. Let me see if I can. Yeah. Led by Tini Babs. I'm not sure if you know the company. They've been trying to like advance AI for African languages and provide API support for like all these type of things that people are interested in.
Okay, is that an API?
Yes,
Or an
they also set up APIs across transcription, translation, things like that.
Okay. But it's not open source.
Sorry?
Is it open source or I have to
No,
subscribe?
no, their models are not open source. But I believe that like if you join their platform, they will give you like a free amount of credits that you can use for your development work. And then from there on it's paid.
Okay, it's exactly like 11 Labs.
Correct. I believe that they do like position as 11 labs for Africa.
Okay, all right, thank you.
All right. So Ibrahim said about the fellowship, what are the requirements? And so like to answer that, I would say that the requirements are flexible, and really it has depended on research interest of myself and Odunayo. So our first fellow, like I mentioned, was a linguist, and that is because currently we are doing a lot of data work, and we really wanted a linguist that can, I guess, bring an informed perspective, right, towards that. But eventually, I think that there will also be people that have, shall I say, a stronger computer science background, especially as you move from this data phase to, where we're doing a lot more training, a lot more evaluation. So in terms of, I think, requirements, I would say that like strong understanding of fundamentals of machine learning would be like really great. I don't expect you to have, I don't expect you to have years of AI experience, but like I would like really strong fundamentals because like the rest can be learned on the job, or like from working. So I would say like the biggest thing we're going to look out for will be like strong ML experience and understanding of fundamentals. So all the usual ML models, logistic regression, the formulas for them, the assumptions, all those types of things. And are we seeking contributors to meet up where I would say yes, we always are. But in my experience, like contributors can really be like a double-edged sword. People are excited to contribute, but eventually don't pull their weight. And you lose a lot of time onboarding people, offboarding people. So I would say yes, we're looking for collaborators and contributors, but we have to find a way to like properly structure it. And that's kind of why we started Tarisco Bounties, a way for us to like put out self-contained tasks that we believe that people in the community can take on and possibly be rewarded for, right? So in terms of like skills, traits to the team and the project, obviously depends on the project, but definitely like having great computing skills has never hurt anybody. I think that, even when you want to do AI research, even when you want to do, even when you want to train language models, right, you require such great software engineering skills to be able to like do different things. So, yeah, having strong like CS, would be really great. Having strong development experience, strong software engineering experience, is always like a really great thing. Right, let me see. Are there any other hands raised? Oh, okay. I see. Anime blanket. All right. We're talking about the Taresco NLP Research Fellowship. We started that this year, and we took on our first research fellow. So I was saying that we think it's something that we will continue into the future. But for right now, we have just one fellow, and we are still structuring our processes, and I guess like improving the way that we work with people, and we will definitely in the future look towards expanding it. So Oak, I would not say that the costs are covered when you use JAX. What I will say is that Google has this thing called let me share it actually, TPU research grant, right? So the TPU research grant is kind of a thing where like you apply and tell Google like, hey, I have this project I want to work on. And then Google is like, okay, like we will give you this amount of compute for a month. And the amount of compute they give you is ridiculous. For example, when I did my thesis, for example, I believe I had grants from both Microsoft and from Google, but like Google's grants gave me, I think, 16 different nodes of TPUs. And that meant that I could train a model that potentially reached up to like 8 billion parameters, but I could train it from scratch. So it's not that you use, it's not that like if you use JAX, your costs are covered. It is the fact that like Google gave me TPUs and JAX is better for working on TPUs. So like I had to make a decision to work in JAX because so I could take advantage of the resources that TPU at Google gave me. So I would say that like it doesn't hurt to know PyTorch at all. And honestly, PyTorch is probably still the dominant way that people train models. Even at work, I use PyTorch mostly. I don't use JAX at work. So it's really not a commentary on whether or not you should use PyTorch or JAX. It was really about this situation, like who was willing to offer me resources to do my work and what framework worked best for those resources. Does that explain things? All right. Any other questions? I'm not sure how to answer that. I did that. So Ibrahim, about the fellowship, I think that later this year we will have more information out about it, and because we currently don't have a website, which is very interesting. Since we started Terresco, we've mainly focused on, I guess, the projects that we're interested in, and most of our communication has been via GitHub. So I think maybe that might be a good place to start. Actually, I'll try to put some information up on GitHub about the fellowship and what we hope to achieve about it. But two things I will say is that one of the reasons I think we won the fellowship, apart from is number one, to help I get more undergraduates and recent graduates get research experience. But also like number two, to get people that are, if you have research experience, it's easier for you to secure a PhD or like an MSc. And we think that that's one of the things that will advance the industry. When more of us can get into research, and you can get into research abroad if you're able to demonstrate prior research experience. So, can I provide the? All right, sure. So the Terresco GitHub. Give me a moment. African Research Collective. All right, so I shared that in chat. Okay. So like I said, there's no information about the research fellowship currently, because we have just one fellow, and we're still improving processes. But as we take learnings and improve and open it up, there will definitely be more information, and hopefully when we get around to building a website, that will also be included there. All right. Any additional questions? What other ways to benchmark on African languages? Well, that depends on what you want to do, right? For example, um, there's a really interesting benchmark, right, that myself and Odo have been interested in creating. It's a visual question answering benchmark, a cross-lingual visual question answering benchmark. And the way that I think of it is this: like, very frequently, old people might walk up to you and say, like, "Oh, what does this signboard say?" Or they might show you a tract and say, "Oh, does this answer this question?" So, like, a visual question answering task is a task that is grounded in some visual content. So, like, one benchmark that we've, for example, been thinking of creating is one where you have an image, and then you have a question, and then a language model, let me say a multimodal language, a multimodal model is prompted to answer the question based on the image. And like creating this kind of data set could be as simple as, for example, going around and taking pictures of billboards and asking a question in Yoruba. All right. It could also be as complex as synthetically creating images and conditioning questions on them. I don't know if that makes sense. But like the way that you create benchmark is to think of the way that you might use a language model in practice, right? And to create a data set that allows you to measure that capability. So in this case, like the capability I want to measure is how well, models can answer questions based on images, and like the way that you create such a data set is to get a pool of images and then to ask questions based on each image and have a ground truth. And then, you can evaluate how well the model is able to answer. And to make evaluation easier, you could even make it multiple choice. Because if it wasn't multiple choice, then I guess figuring out what is the correct answer could also be complex and require LLM as a judge, right? So like to simplify it, you could even make it a image, question, then options. Then the model is to pick which option makes sense. So that's like one way you can create an evaluation benchmark, for example. Similar one says, how do you get and pre-process data for evaluating mathematical reasoning in African languages? And so this is like a really interesting question. And like we wrote a paper about it earlier this year. To be honest, it wasn't a great paper. And like it's something like we still want to improve. But like we had some ideas how to start. The first way you can think of is to directly translate. So you can get mathematical reasoning data sets that exist, something like BMath, MathQA, and then translate them to African languages, and then see whether when you take the questions and prompt a language model, the translated question, which is now in Yoruba or in Igbo, see whether the models are able to answer. That is one way, that you can evaluate, right? A second way could be, for example, to synthetically create questions. And that is something that we explored. So like a pipeline that is able to create mathematical questions that make sense and that are verifiable because we already know the answer. And then to take those questions and then prompt a model and then see whether the answer that it gives you matches the answer that you expect. So I would say there's a variety of ways. It's just if you really want to do it, I would say the first thing to do is to like do a survey of how people evaluate mathematical reasoning in English, right? So like once you do a survey and understand how people are doing the work in English, the rest is just how do I do this in African languages, right? So if you're interested in that area, I would say like start like that. Find out the English papers that look at mathematical reasoning, and then figure out what makes sense to do in African languages, what doesn't. How can I translate this to African languages, etc., etc. So for example, you might decide that there's no point trying to do graph theory in Yoruba. And I would agree with you. But like for simpler things like arithmetic, I could see why you want like to pursue arithmetic in African languages, and like why that might be an area for you to, devote time and resources. Does that make sense, Similoluwa? All right. So I think Sean shared our paper. And that's not a paper. Let me share Odun's paper, Improving Mathematical Reasoning. African Languages, Odun Ayo. Yeah, so I'll share Odun's paper. Odun was the one that led the paper. And I think it was the first attempt at improving mathematical reasoning for African languages. There's still a lot of holes in the paper. So like if you think of anything, I'm sure that what's it called? I'm sure you can reach out to Odun Ayo. And he might be interested in working with you.
All right. Thank you very much, Akintunde, for this session. If you guys can go through the chats, you can see the feedback form over there, and feel free to drop your feedback for this session. Thank you all for joining the call. As usual, the call will be posted on our YouTube, and you can go there anytime you like to visit it. Thank you very much again, Akintunde. Good night, everyone.